Yes, very good morning. Very good morning.
Good morning,
yes.
sir.
Have you seen my message, dear gentlemen? Vignesh, Kabilan?
Yes, sir.
See, still the number of attendees is very minimal. Still, without further delay, we'll start our session. Because today I have scheduled till 10:55. I have another meeting during 11 o'clock. So we'll continue till 10:55. Hope my slides are visible.
Yes, sir.
In the last class, I started to share the content related to the iteration method. Today we will continue the iteration method. Before that, I refresh with iteration method. This is what the condition, that is, let x is equal to alpha be the root of the equation, that is that we are going to take as f of x, and which is equivalent to x is equal to pi of x. Let I be any interval containing the root of the root might be alpha. If the modulus of pi dash of x is less than 1 for all the intervals, that is I, then the sequence of approximation will converge. Otherwise, it won't converge. If it is not less than 1, it won't converge. So we need to depend some other technique to get a solution for that particular condition, and this will be very useful for finding the infinite series solution for the infinite series, and these things we discussed in the last class. So you please take your calculator. This is I think 13th class. 12. Just a minute. I'll request some 5 people. 60. I think last batch. Last 5, you please. Last batch. Last set of 5 students, you please join with us till the end.
Yes, sir.
Yes. Yes, from 115 to 120. Vignesh, Vikash Kumar, Vikram Vijay Lakadia, Vijay Tiraj. Please unmute your mic. You please join with us till the end.
Yes, sir.
Yes. And the differentiation of log x, we were log base 10x we were discussed in the last class, and in continuation with yes, you please make a note of this particular problem, that is problem number 12. Find the real root of equation 1 minus x plus x square by 2 factorial whole power 2 minus 3 power 3 cube by 3 factorial power 2 plus x power 4 divided by 4 factorial power 2 is equal to 0 by iteration method. The what we need to do, we need to take x alone in order to consider that as an pi of x. The given equation is considered as f of x, and the pi of x has to be taken with the aid of x alone. So the rest of the terms become 1 plus x squared by 2 factorial power 2 minus 3 cube divided by 3 factorial power 2 plus and so on. And what we need to do, we need to get the information related whether the results will converge or it will diverge. So for that we need pi dash of x. Before that, what we can get the where the result zones are available, that we can get through this. Thank you, Pradeep. Omitting x square, what we can do, and higher pass of x will get x is equal to 1, right? So we can start our iterations with x as 1. So our x naught is equal to 1, and see, this is what the first results, and you try to get whether the pi dash of x will will return the positive value and check and then continue this exercise. So here the pi of x naught is equal to 1 plus 1 square divided by 2 factorial. You take your calculator, I'll tell you how these can be solved very easily. See, this is what your execution. You type 1 plus science square. Vignesh,
So
take your
yes, sir.
calculator. Yes, before that you give your number of digit as 4.
Sir, it's infinite series, and I mean, like, how are you?
Yes, infinite we cannot proceed
So
with
we take
4.
out these three. So, okay.
Yes, first of all, I'll tell you one by one. What you can do, you give your mode and fix your digit as 4. Fix your number of digit as 4. Then you type this equation, that is 1 plus open bracket answer square divided by 2 factorial, where you can find your factorial in the calculator, where you can find your factorial. See at the second row from the top. Yes, of course, x inverse. Give
Yes,
shift
inverse.
and yes, give shift and then give x power minus 1, you'll get factorial and whole power 2 and again close the bracket minus open bracket answer power 3 divided by open bracket 3 factorial bracket power 2 close again close bracket plus answer power 4 divided by open bracket 4 factorial power 2 again close bracket. It continues, but that won't be feasible. You try to stop your iteration with 4 set of data. So you now give equal to what is the result. Before that, you give answer as answer. What is our answer? What is our x naught? Answer is equal to 1. You give 1 and then give equal to that that will be stored in answer. Again, go back to your equation. Now give equal to what is your result?
1.2240.
1 point? Yes, 1 point. 1.22.
40.
Very good. 1.2240 is your result. Yes, that I have written here. That is 1.2240. Now again, you give equal to
1.32.
So 1.3275.
very good. Again,
1.3810, sir.
very good. Then
1.4099, sir.
very good. Then
1.4260.
of course, continue. Yes. Again,
4350.
yes. Then
1.4401.
very good. Then
1.4430.
then
1.4446.
yes. See, this is what our x9. During your x16 and x17, you are getting the same result. For the results are accurate for with 4 digit. That is 1.4467. And you try. I'll wait whether this is our x9. X10 will be 4455. X11 4461. X12 4464. X13 4465. 15 4466, 16 is 4467, and 17 is also 4467. Whether my results are concurrent, dear gentlemen?
Yes, sir. It's coming.
Yes, sir.
Yes.
Yes.
So yes, but doing the information manually will be very hectic. So you please aware about the easy procedure to do the calculation with these iteration or any other method in particular in numerical method. So the calculator, the efficient usage of calculator is essential. So that this is what our results in particular to this problem number 12. So this is what your practice. Find the real root of equation x minus x cube by 3 plus x power 5 by 10 minus x power 7 by 42 plus x power 9 by 246, that is equal to 0. This is see, this has to be considered as f of x. So pi of x, you get the pi of x equation by taking x alone on the one particular side and continue your iteration. So this is what about the iteration method. What are the other topics we were covered during unit 3? The iteration method and summon.
Newton drafts.
Yes, Newton-Raphson method. Very good. And now we'll approach the regular falsy method, the method of false position or the regular falsy method. So before starting with these regular falsy method, we need to know some basic information about the various solutions and its boundaries and the regions where we are going to get the roots. And so see, this is what you studied during your school days, that is the root of an equation, that is ax square. If it is a quadratic equation, that is ax square plus bx plus c is equal to 0, the results you can get x from minus b plus or minus root of b square minus 4ac divided by 2a. But when we are having a higher order equation, how these x can be found, that is what our objective. I have given the 5-part equation, and see, when there is an equation, non-linear equation, we were already taught about the linear and getting the results for linear and non-linear. That is what we were started with unit 2. And sin x plus x is equal to 0. Then what is x? And for that, see, the nonlinear equations always maybe either a bracketing method or a graphical method or a open method. That is what we solved with. We started with Newton-Raphson method, and one among the open method is also season method is also available, but our syllabus is restricted with Newton-Raphson method. But the other hand, we are having the bracketing method. What is mean by bracketing method? The results has to be taken from the bracketing method, that is bisection, or there are two methods are available in bracketing. One is bisection, the other one is regular falsy method. All these are iterative methods. So in bracketing method, there are two point methods for finding the roots. See, the two initial guesses for the roots are required. The so these guesses must bracket or be on either side of the root. Consider this as an interested line for finding the root. So one of the real and the continuous function, that is f of x is equal to 0, bound by the values of x when x is equal to x1 and x is equal to xu, then the function of these x1 and xu, the cross product of function of x1 and xu less than 0, the function changes sign on opposite sides of the root. So these are the some other peculiar set of results for the various curves. See here, this curve doesn't meet this curve that there won't be any meeting with the x-axis, so it doesn't have any real root in any root. So the other curve depicted in picture B has only one root. And see the equation or chart C, this curve has two roots, and concerning this particular case, that is D, there are three roots. So and for this we need to have there are boundaries. That boundaries would be either xi and xu. Other curves are shown here, and two roots. There are two roots are here, and here discontinuous function needs special method for getting the results. And see, this is what the sinusoidal wave functions. What we can get, there are many roots for these cases. That is, f of x is equal to sine 10x plus cos 3x, and this has many roots between the 0 to 5. So this is what the open method. See, there are three different pictures detailing about the open method. That is A, B, and C shown here, and open method are based on the formulas that required only a single starting value of x or two starting values that do not necessarily the bracket the root. So the simple fixed point iterations, the rearrangement of the given function of x on left side and getting x on the other side. What we did in iteration method, that is explained in detail here. The bracketing method are convergent, and the fixed point method the many times diverge, but it has its own disadvantage, as we seen. When the modulus of pi dash of x is greater than 0, at that time it won't converge. So depending on the starting point, that is initial guess, and how the function behaves, so it is we need to use efficiently the calculators not to get the results. So these are some iterative method rearrangements. So f of x is equal to x square minus x minus 2. The x is greater than 0. X on one side we can keep x, and on the other side we can take the x square minus 2, or this can be written as with the aid of this x square we can get other equations too. That is what here x is equal to root of x plus 2. So even we can get this, that is x is equal to we can take it out, right? From this we can take x out, and what we can get, we will get 1 x plus 1, and then that rearrangement will give the x is equal to 1 plus 2 by x. So the condition would be the pi dash of x is equal to the pi dash of x is, should be greater than less than 0. This is what the results when we are approaching this with the Excel. You try with your Excel. That is, this is what the pi of x for this three different cases. That is 1 plus 2 by x and x square minus 2, x plus 2 the whole power 1 by 2. So this is what the initial guess. In all these three cases, what we are depending the same initial iteration. The initial iteration be 1. So in the first case, the results are 3. The second case it is minus 1. In the third case it is 1.732. So see the appropriate selection of the function, that is pi of x, will beneficial for getting the results in the earlier iteration. So this seems that is in the earlier iterations we are getting 2 2, and concerning this particular case at the latest stage we are getting, see, when the pi of L is negative, the results won't converge. So this won't be suitable method for solving the iteration method, and the appropriate selection has to be taken for getting the solution in the iterative method. And see, by continuing this, what we are getting, when I am taking my initial approximation as 0, and the first method won't return any useful information, because we are having the denominator as x, so that might be very hard to find. So here the results are we are getting in the third iteration itself we are getting the results as 2. But see here, the third method will be beneficial in both the cases, and see, the convergence has to be when the x is equal to pi of x can be expressed as a pair of equation, that is y1 is equal to x and y2 is equal to pi of x. That is the component equation which we are deriving from the f of x. So plot them separately. This is what the f of x. See, when the f of x is equal to e power minus x and minus x, and our f of x1 would be x, and f of that is f2 of x would be e power minus x. I am trying to divide with two equations, and so the fixed point iteration method converges with the pi dash of x is less than 1, that is the slope of the line f of x is equal to x. So this is what the linearly convergent method, and this is what we seen in the iteration method. And now the root finding algorithm, that is bisection method. From the next class we will approach these bisection method for getting the solution. And do you have any queries with today's class, today's lecture? Do you have any queries? And you please solve one. I have given only one problem for your practice today. You please try to solve that. Anyone approached or anyone found the results for this particular problem? Anyone found?
Which problem, sir?
So can you show me the sequence again?
Yes. Problem number 13.
Sir.
My slides are visible?
Yes, sir.
Yes, x minus x cube by 3 plus x bar 5 by 10.
Sir.
Yes, tell me.
Sir, in the last class you explained till example 8.
Okay.
So what about the example 9, 10, 11?
Yes. What you are asking, right?
Sir, can you share this PPT?
See, once the class is over, at that time only I can share. Now
So
you copy down everything. Otherwise, you will become lazy. You won't copy. To try to copy.
Sir, I am saying that.
Which portions are essential?
Sir, I am saying that you don't.
Problem number 8.
You don't.
You are interested to find problem number 8.
Sir, you don't explain question number 8, 9 and 11. 10, 11.
8, 9 and 11. 8, 9 and 11, right? Pardon. I think Anshu.
Yes, sir.
You encouraged,
Sorry, sir.
You inquired about the problem number 8, 9 and so on, or some
No,
other fellow asked?
Sir, I am saying that you don't. We don't see the question number 8, 9, 10 and 9, 10, 11 question. You
9,
forget
10,
to explain these 3 questions in
9,
class.
10, 11 not yet explained. That is what you were.
Yes, sir.
9, 10, 11 not yet explained.
Yes, sir.
See my slides. See my slides. Whether that is essential, well, I'll tell you. See, this is what our problem number. Yeah, I have requested you to solve, Anshu. This is what your problem number 9.
So you don't give this as a homework to us also.
I didn't explain. These things I didn't explain.
No, sir.
We didn't solve. Yeah, I think this is what we solved, Anshu. In the last, so you see the video. You see the video. I have explained this exercise. What I have solved. This is what I have explained. This exercise doesn't have any problem number. I have explained this thing, and with similar content, I have requested you to solve this problem number 9 and problem number 10. Because these are very concurrent and it is very simple. And even we have solved this problem, right?
Okay, sir.
Log x, in which problem we were disseminated the log x differentiation integration? Problem number 11, right?
So that is question number 6.
That is in problem number 6.
The differentiate
Yes.
log.
Question and 11th question we didn't discuss.
Yes. No issues. I'll explain these 9 and 10 in the next class. Yes. Thank you for reminding me, Anshu. Okay. Today we'll wind up our session. I will meet during the tomorrow's class.
Thank you, sir.
Yes. Yes. Thank you. Thank you. We'll meet.
Thank you, sir.